Graphing nonlinear inequalities. In this video, we're going to graph nonlinear inequalities in two variables. Okay, let's graph this line. What if instead of the inequality symbol, I wrote an equal sign here? Do you recognize what type of equation or function this is? Well, if you said quadratic, then you are correct. The parent function here is the quadratic function or the quadratic equation, y equals x squared. Now, what did we do to that parent function? Well, I can see here there was a horizontal, two different types of transformations took place here, and right here in the back we have a vertical. So a horizontal translation, did we slide that to the left or to the right? If you said 2 to the right, that is correct. And vertically shift that, what is it? Yes, 3 units up. So I just wanted you to see that this was just simply the graph of a parabola that has been shifted to the right 2 units and then 3 units up. So let's go ahead, let me erase my screen for a moment and we'll take a look at what that graph is. And before I sketch that parabola, is that going to be a dashed or is that solid? Well, let's take a look at what we have here. If you look at the inequality symbol here, it means we're going to sketch a solid parabola. And so there's the graph of my parabola, over 2 units and up 3. All right, next we have to decide what region are we going to shade. Now, since the equation is solved for y, we can go ahead and use that boundary method to determine whether we shade upper or whether we shade lower. And recall that when you have greater than, that means that you are going to shade upper. So upper for a parabola would mean the part that is up top, which means if you are not in upper, every other region then would be lower. Okay, so our boundary method already told us to shade the upper, so once we shade that, we are done. And there you have it. There's the graph of the parabola.